Hey guys, I noticed when I was editing that this part of the video kind of had portions missing. I had to re-record because I wasn't recording properly. Yeah, so when I do the Math Olympiad paper, some of the Math Olympiad papers, because this is a very long video, it's 40 minutes, I will do this problem with you. I found this problem on pre-math. If you do want to check out the YouTube video, you can. Also, when I do these problems, I don't solve them pre-recording. I go in and I solve it with them. So if there's any confusion on like how I think and stuff, you can drop it in the comments. But I just want to show how I think about problems and how I get into solving them, instead of like practicing them and solving them before and then that. So because of that, I'm gonna choose a different problem for this, and you will kind of go in the mindset of how to solve these problems. So enjoy. Thank you. So the second problem requires you to know that cast thing. So the first quadrant, second, third, then fourth, right? So C, first quadrant is A, sorry, O, and you kind of see where things are cast. So yeah, it's kind of 0 here, 360, 90, 180, 270, and you can use the provided sheet for a thing, because this, I think it's N3 maths. I got a request from someone to do this type of problems. I think it's the latest paper I could find, and this is question 6, like the first question 6, and it was worth 7 marks, so pretty a lot of marks. So with identities, kind of weird, isn't it? Yeah. So we know that the thing changes when it's a 90 degree, because you kind of changing this way, but when it's a 180 degree, you're keeping your thing intact. So just know that this 90 degrees minus and 90 degree plus, it's gonna change to sign and it's gonna change to cos. The reason for this is, it could be explained many ways. I'm kind of gonna try explain it the way I understand it. So if we have a nice sine wave here, and we then have, I don't understand this Photoshop. So here it's peak at 90 degrees. And here it's peaking at, here it's peaking at 90 degrees. So this is 270. So, and this is 90 degrees, right? 90 degrees. So when you add or minus, so when you shift the graph 90 degrees, what's gonna happen is, I am not understanding how this thing works. What's gonna happen is, you're gonna be taking the starting point from here, right? So your starting point is gonna be from there, and at 90 it would be then, because this is 180, at 90 it would then be 0, and at 180 it would be 1. So this is 1, sorry, minus 1, minus 1. and at 180 it would be 1, and then at 270 it would be 0, and then at 360 it would be 1. So if you see the way this yellow graph is, it's resembling a cos sine graph. The red is resembling a sine graph. It's resembling more of a sine theta or whatever graph. So this shift, whether it's minus or plus, because this is a minus shift, if it was a plus shift, because remember the graph is ongoing, even if it's a plus shift, it would then still change to a cosine graph. It will resemble a cosine graph. That's why you have, when you add 90 or 270, you have those changes, right? So to figure out if a change is positive or negative, it's really easy if you use the cos thing. You could draw the graphs. You see when you shift it on minus, what happens? It's going down, so it's going to be negative, and if you shift it at plus, it's going to be positive. So cos at 90 degrees plus would be in the sine thing. So we know that this is sine, and if we add 90 degrees to it, it's gonna be positive. Just want to confirm that real quick. Yeah, so when you do that, it's gonna be in the minus sign, and you can see if we have this cosine and we add the 90 degrees, so if it's here and we add the 90, okay, to be honest, it's just a negative sign, positive sign, whatever. Yeah, so if you have cos that you're gonna have that in the negative thing, but it's also squared, which is a problem, because sine x times sine x is equals to sine squared x. So if you have this square, it literally means cos 90 plus x all squared, which then is not the same as all that. So what that means is that this, though it is minus sine, the identity would become plus sine because it is squared, right? And then all over. Now sine 90 minus x, it's going to be cos, of course. And to figure out whether it's positive or negative, we have in our sign, and it's gonna be positive, yay. So it's gonna be positive cos x, right? So let me just write this properly using a proper color. I am so confused. Okay, see, see, so it's gonna be sine squared x over cos x. This identity, if you remember that sine squared x plus cos squared x equals to 1. If it's just that, you just know that it is plus cos x squared. Oh, sorry, not cos x squared, cos squared x. So sorry if you want. Equals to 1 minus cos x over cos x. So we're trying to prove that the left side equals the right side. Pretty nice. We're in a good place. So we have this equaling this. So now we can do like any side, but let's just choose this. So what do we know about that? 1 minus cos squared x over, if I take out cos x, I'm gonna be left with 1 plus cos x. And if you know where this is going, this would be 1 plus cos x, 1 minus cos x over cos x, 1 plus cos x, and this minus that. That means this is 1 minus cos x over cos x. So you did prove the identity, which is, yeah. So our final problem is a nice problem. It's the first question, so I was like, let's end on a more easy and dry level. We started pretty level, so those videos all kind of level 1, but yeah, so I might need more space for each, so I will make space and I'll make layers for it. Yeah, so simplify this baby. So what I'm thinking is just we need to have an identity. Not an identity, a square. So what is 49 x squared plus 56x plus 16? Right, so 49, for it to be, will be 7x, and whatever we're adding on the 16, when we multiply it, it has to, yeah, so it's gonna be 4, and these are both pluses. So we want to prove that this will take us back to that, right? It's just by intuition, right? So what is 7 times 7? 49x. 7 times 4, 7, 14, 21, 28. So plus 28x plus 28x plus 16. And this takes us right back to that. So we saw the identity. So literally the job was to just get this identity and make sure that it is that, and if we kind of do that, we'll have the square root, and simplifying this then equals to plus or minus 7x plus 4. Don't forget the plus or minus, because it's important. You never know. You can try do other things, but you never know. So let's gonna do the second question. That's why I wanted to have layers of it. Usually I would probably do this all of question 1 in one paper, and if I want to skip around questions and like do question 3 before I do question 2, kind of laying out like simple questions first, and I know that my brain is fresh and I'm not gonna have any mistakes, and then do like the kind of more challenging questions afterwards. So yeah, it's pretty better to write it that way. So we're gonna simplify this, which looks really long, but if you simplify it, you'll simplify it. So we have a over 3 minus a minus 2 over 3, right? Times a plus a minus 1 minus 2 all to the minus 1. So I'm gonna write this properly, and I'm kind of using very big font here. Over a plus a to the minus 1 minus 2. Okay, bit scary, but we're gonna keep it. So this would equal to a minus 1. So I want to take out a to the third. Not really. Let me not do that yet. Let me do this. 3 times. No, wait, no, that's wrong. These are bothering me a bit, but let's kind of go with them. Minus a minus 2 over 3 is over a plus 1 over a minus 2, right? So here I'm gonna take out something, so I'm gonna leave the top as it is, and then we're gonna have this, and then we're gonna have a squared plus 1 minus 2a all over a 1 over 3 minus a minus 2 over 3. We're gonna then have this multiplied on the top, so we're gonna have a 1 plus 1 over 3 minus a 1 minus 2 over 3 all over a squared minus 2a plus 1. This was that will be a 4 over 3 minus a 1 over 3 all over a squared minus 2a plus 1. So I wanna take this out, and what do I know about this? I know that a 1 over 3 multiplied by a will give me that and that, so minus a 1 over 3, because I had it here, all over a squared minus 2a plus 1. So I'm gonna take out a 1 over 3. I'm gonna be left with a minus 1, and then I'm gonna have that thing I always have with the factors, a, and both minus are gonna yield to plus. So I'm gonna have one of them gone, and I'm gonna have a 1 over 3 all over a minus 1. For me, I don't think I can simplify anymore to TBH, because this equation equals to root of a over minus 1. So guess that's where I can end, but tell me if you guys wanna do more steps. But yeah, 7 marks. I don't know. 7 marks kind of is a lot for it, given how simple the problem was. But I ain't gonna judge. Um, so let's do the final one. This one, 6 marks. It's less than the other one. So I'm gonna do is immediately write it as multiplied because it's just gonna swap the thing. So we're gonna have 3x squared minus 7x plus 2 all over 2x squared minus 5x minus 3 multiplied by x squared minus 9 over x squared plus x minus 6. So immediately we have that, and I'll start factoring out stuff. So this top competitor 3 kind of has itself in 1, so it's going to be 3x and x, and 2 also has itself in 1, so it's going to be 2 here and then 1, because the positive, so 6 minus 1, so we'll get that all over 2. Also it's only itself in 1, so 2x x 3, because it's negative, I'm gonna have a negative and positive, so I'm gonna put 3 here minus, and I'm gonna put 1 here plus, so you're gonna have minus 6 plus x multiplied by, you see this is that cabinet good, so sorry, there you go, x plus 3 all over, so we know that there's 3 and 2, 1, it's vector because it's minus, we're gonna have so some plus and then minus. I do great, we have we're left with just 3x minus 1 over 2x plus 1. So kind of confusing because this is 6 marks and that took 3 steps. I don't understand the marking system, I am not gonna lie, but yeah, okay, so so doing the last problem, okay, there you go, says if 16x cubed minus px squared plus 12x plus 3 divided by 2x plus 1, the remainder is minus 7. So once they mention the remainder and seeing that this is a polynomial, I immediately thought of the remainder theory. So before we go there, what is the remainder theory? The remainder theory states that if we have a polynomial, let me write this one right. So we have a polynomial, maybe x cubed plus 2x squared plus x plus 1 over x minus constant, so let's say a. The remainder of this will be equal to, if we take this polynomial, let's call it f, substituted by a, where x equals to a. So if this is plus, then it would be minus a. That's the remainder theorem. So what they gave us is they gave us this, they gave us that, and they gave us this, and they want us to solve for this, right? So I'm gonna write it here. Remainder theorem. It's kind of weird to put it in a algebraic paper, but all the things have happened because it is kind of functions, so I wouldn't say that it's that wild, but so we have now 16x cubed minus px squared. Also, knowing that it's 4 marks, this is 7 marks. Knowing that it's 4 marks is yeah. So yeah, so there minus 12x plus 3 all over 2x plus 1 would equals to minus 7. So we have then x equals to minus 1 over 2, and to solve this, remembering this is because of the substitution of half. So half cubed would be 16 times minus 1 over 8. Half squared would be p times 1 over 4. Minus half would be plus 12 times half. I'm already substituting for the stuff. This half, yeah, sorry, so we don't need the equals to minus 7. So we have 2, so minus 2 minus p over 4 plus 6 plus 3 equal to minus 7. Let's not use a calculator. How about that? Minus 2 plus 7 plus 6 plus 3 equals to p over 4, and p over 4 equals to 9, 16, 16, 14. So 14 times 4 would be p equals to 4 by 4, 16, 6. 4 by that, 4, 66, is it? Just check. 16, carry 1, 4, 4, 5. Okay, so 56. That's good to check. I'm putting calculator. So p is 64. And I think this is pretty decent for, I mean, like here you could just solve the problem, but I just went the extra mile because I didn't want to use a calculator. But yeah, so I guess how do I, yeah, it's that. If you have problems with such questions, so these are 1.2 questions. The last question is always a level 4 question. So highest question you would have had to study like some extra things or understand maths to a high level, to not really high level, but all like levels, to be able to solve these kind of questions. So yeah, see you next time, guys. Bye.